Okay, the next question that we are looking at, this is a continuation in the videos of implicit function. So the next question, which is B, it is going to be um, ln x plus y plus x y squared equals 0. Remember the question was solve for dy dx. So we are solving for dy dx if we have been given this function which is on top. So our solution, we know that from the previous video, we know that dy dx equals crosswise negative partial derivative of f with respect to x. They should be always opposite. Then from there, we need to let the function which is on top. It may look like a shortcut, but if you watch the first part, which is having part A, you will understand why I'm not explaining much on this. So we let partial derivative, we let f, then we check the letters which are there, or the variables. We have got x and y, and then we let it to be our question. So it becomes that one. Then from here, our duty is to find dy dx. So we are going to find partial derivative of f with respect to x, and again we are going to find partial derivative of f with respect to y, and then come and replace them respectively. So after having the function, this one which is down here, that's when you can go for this. Okay, we start finding partial derivative of f with respect to x. Okay, so here we have ln x plus y plus x y squared. Then we just want to differentiate with respect to x. So what we are going to do, allow me to wrap the top part. So I want to differentiate this one. So let me just push it up. We said let f of xy equal to ln x plus y, and then plus x y squared equals 0. That is the question which we have. So now we are finding partial derivative of f with respect to x. So we have to differentiate at this point and at this point, because this is a term and this is plus another term. So we want to find partial derivative of f with respect to x, or in short, we are differentiating this function considering only x. So here we have this guy, which is I'll ignore this. We just say taking this guy ln, this is L, ln x plus y. So from the basic, from y equals ln u, when it is like that, when we are differentiating dy du, the formula says just say 1 over what is here in the brackets. So it will be, so this applies if you're differentiating a ln. It will be 1 over what is in the brackets times the derivative of what is in the bracket. So that is the formula to use when you're differentiating a ln. So it will be 1 over what is in the bracket. So this is what is in the bracket, 1 over what is in the bracket, times the differentiation of the same thing in the bracket. So in our case, we have ln x plus y, and then we want to differentiate it. So following this formula, we are going to have 1 over x plus y times the derivative of this guy. But remember what you're following? You're just following x. X is your letter under consideration. So we have ln x plus y. But in our case, it's only x which is important. So where there is no x, we said in the previous video, the answer is 0. And where there is x, if it is just a letter on its own, then the answer is 1. So watching part A will help you understand this one better, because it's like most of the concepts we already covered in the first video. So when we are multiplying, we just multiply the top over x plus y. So this one is just like 1 over 1. So we multiply straight. When you're multiplying fractions, whenever fractions have been multiplied, you multiply straight, like that. So this one, the top on top, bottom on bottom. So in our case, we're going to have this one. So this 1 over x plus y is our derivative on this part, considering x. Now let's consider x at this point. So we have xy squared. If we differentiate with respect to x, x is alone, but it is attached to this theta. So if it is attached to a variable which we are not considering, treat it as a constant, or in short, just let it follow. So after x is differentiated, we are just getting y squared. In that case, partial derivative of f with respect to x, for this first part here, it is this answer, which is 1 over x plus y, plus the derivative at this point, considering x, this is the y squared. So that is the case. At this point, allow me to clean what is not necessary for the next question. Okay, so this is our partial derivative of f with respect to x. So now, I have not deleted this one because I know it will be useful for y. So in the case of y, these two, they are just the same. So we expect to have the same answer per first. The only thing which will be different is the second part. Let's consider y. So we are differentiating this guy considering y. So the formula says if you've got a ln of something, it is that something below 1 times its derivative. So in our case, it's 1 over x plus y times the derivative of this, but just considering what? Y, because in our case we are finding now the second one, which is partial derivative of f with respect to y. So considering y, here there will be 0 and then 1, which gives us the same value. The other thing that we have to do is to differentiate on the next. We are considering y. So we have this part, but considering only y. So x again will just be taken, or it will follow your answer. So your consideration is y. So y has got a power 2. The power 2 will drop. It can't come in between, but in front. And then there is x there. And then this power has to reduce. So in that case, your partial derivative of f with respect to y is equal to this value, 1 x plus y, and this other value, which is 2xy. So these are our two values. We have to simplify them further so that we can see some cancellations. So allow me to clean so that we move forward. So I'll take this guy, partial derivative of f with respect to x is equal to 1 over x plus y squared. So I know something that will happen there. So suppose you've got a over c plus b, then your answer is as simple as saying what is on your denominator should follow, then cross multiply and follow the sign. So take what is on your denominator. Your denominator is C. Take the numerator, which I've written there, then cross multiply and follow the sign. So we cross multiply are going to have CB and put the sign which is there. Then maintain the denominator. So that is the formula there. So hopefully that formula will help. So we are going to cross multiply, maintaining the same numerator. The numerator will be maintained. Then we'll cross multiply this one and this. Excuse me. And then maintain the denominator. So using this method on this part, we can now multiply the top, xy squared plus y power 3 over x plus y. So that is our simplified partial derivative of f with respect to x. So I'll take this value and replace it in here, just for keeping it. So we have partial derivative of f with respect to x, giving us 1 plus xy power 2 plus y power 3, then x plus y. Allow me to clean this so that we can simplify this one as well. In the same manner, we get partial derivative of f with respect to y. We have 1 over x plus y plus 2xy. We use the same method, which we said if we have this, then it is equal to maintain your numerator, then cross multiply c and b plus c, while it's maintaining the same denominator. So with this method, if it's a minus, there will be a minus there. So we follow up, we maintain this one, then there's a plus, and then cross multiply these two. So 2xy will be outside and we'll multiply this guy as you maintain x plus y. From there, you will expand. Sorry. As we expand, it will be 2xy multiplies x. So the x will increase in terms of power. Then goes that side, the y's are the ones to increase now in terms of power. Okay, so this is now like our final value for partial derivative of f with respect to y. So we also keep it here. So partial derivative of y of f with respect to y equals 1 Okay, we can now clean this. So going back to the formula, we are finding dy dx. The formula says, so that's what the formula suggests. So in our case, we have to replace. So dy dx equals negative. So we can see that what is coming are fractions. So if we are bringing up fractions, I suggest you use the division, that one which we were taught on during lower grades, which is this one, just for the sake of easy calculations. Instead of mounting fraction after fraction, we can just put the fraction to the left and to the side, to the right, as they are separated by the division symbol. So I'll take the top, which is this one. Remember there's a negative, which is here, and bracket. Then fix that one, which is 1 plus. So that is it for the top. There is this bar, which now turns into a division. And then we get the other guy. So looking at these guys, there is a division, and we are dealing with fractions. We know what happens during the division when you're dealing with fractions. These guys will swap. So we'll put a multiplication symbol here, and then this one will go on top. In short, they will be reciprocated. So they will reciprocate as this one goes on top, and then the numerator becomes the denominator. And then we are free. Oh, sorry. There's a negative here. Now we are free to cancel or divide these guys. After that division, we are free to distribute the negative or keep it outside. So just distribute it. As they multiply with 1, so it will just be this one. 1 times anything, the answer is anything. Then I will also multiply this with 1, which will be the same thing. So this marks the end of our dy dx question.